Okay, we're going to go through this 5-7 is on numerical integration, but it's the trapezoid rule and Simpsons rule. Now let me explain it. In most calc books, you guys started out and you did the area underneath the curve using rectangles. Remember I sent you to the board? That took a long time, and then we did it on the calculator using RAM, the RAM program, rectangular approximation method, and then we also used area. And that one drew the picture for you with the rectangles. Okay, most calc books do this integration in this order. Most calc books do rectangles, trapezoids, and then the actual integration. Your calc book does rectangles, which is an approximation. Then you did the integrals, which is the exact area underneath the curve. And now your book comes back later and does trapezoids. So we're going to do trapezoids, and we're also going to do what they call the Simpsons method, and that's by parabolic arcs. Trapezoid method, Simpsons method are both approximations just like the rectangles. The actual area is the integration. Okay? Okay, so we're going to go through the notes today in one example. Okay? And this will go in for 5-7. Okay? I'm actually going to show you how these formulas are derived, and then we're going to add the formulas to your card. Okay? But I think you need to know where these formulas come from. Okay? So this is called numerical integration. And we're going to do the trapezoidal rule. And Simpsons method. Running out of room here. And Simpsons method. Trapezoidal rule and Simpsons method. First, you have to go back to your 5th, 6th, 7th grade math when we did trapezoids. Trapezoids had one pair of parallel lines. Might look like this for a trapezoid, and in geometry we marked it like this, where this line's parallel to this line. Okay. When we figured the area of a trapezoid, the area of a trapezoid is, you can write it 1/2 times the height, or you can write it the height over 2 times the sum of the bases. And I'm going to label the bases like this base along here would be our b sub 1. This base up here would be b sub 2, and the perpendicular distance is the height. So a trapezoid might look like that. It might have also looked like this. Some trapezoids, they might look like this. Okay, it's still, one pair of parallel sides. Okay, and if this is a perpendicular, then this would be the height, this would be the base, this would be a base. Still same formula for the area. Okay, so it's one pair of parallel sides. Okay, now what they're going to do on our graph is they're basically going to take a figure like this and tilt it so it looks like this. So the parallel lines are here, okay, and then it'll be something like that. Okay, so it's going to be like standing on its end, standing on the height. Okay, so an example. Just kind of draw a sketch here, and I'm going to give you a curve, something like that. Okay, drop a perpendicular down, and the easiest way to divide this into 4 slices is estimate half of that, drop a perpendicular. Okay, cut that one in half. Cut that one in half. Cut that down, and then cut that one in half. So you got 4 slices. Okay. Okay. For each one of these, we're going to estimate the area underneath the curve by using trapezoids. So here would be our estimation. Instead of making it a rectangle, and you can tell if I made this a rectangle up here, the trapezoid's going to be a better approximation. Okay, if I made it a rectangle down here, trapezoid's still a better approximation. Okay, for all those, we would just make it a trapezoid and that one's going to be close to a rectangle, but still a trapezoid. Okay. For the perpendiculars now would be down here, and each one of these would represent the height. Okay. So now the bases are actually on the side. So this would be my y sub 0. This distance here would be my y sub 1, y sub 2, y sub 3, and y sub 4. Okay. So now, if I find the area, okay, I'm going to do T for the trapezoidal rule, okay, and the area of each trapezoid. So if I look at this first trapezoid, okay, it's actually the h over 2 times the sum of the bases, and my bases are y sub 0 and y sub 1. Put that in parentheses and then bracket. Plus, for the second trapezoid, let's look at this one. Okay, for that trapezoid, it's going to be h over 2. And now my bases are y sub 1 plus y sub 2. Follow what I'm doing? Okay, plus the third one. Okay, if I look at this one, my bases are going to be y sub 2 and y sub 3. Still h over 2. And y sub 2 and y sub 3. The last one is going to be h over 2 and, oops, times, sorry, what's one thing there, times y sub 3 plus y sub 4. And that's the last, so there's 4 trapezoids there. Okay, now, what's in common in each one? If you look, what's in common in each term? I'm going to take that out. Okay, so if I take out the h over 2, and then you see that I would have 1 y sub 0. That's the only one of those. So I have 1 y sub 0. If I add, here's a y sub 1 and a y sub 1, so I'm going to have 2 y sub 1s. Follow what I'm doing? Plus, how many y sub 2s? 2 y sub 2s. How many y sub 3s? 2. Now how many y sub 4s? Just 1. So I'd have y sub. Okay. And on this specific case, that's what it would look like. Now, if I did this in general, where I had more trapezoids, okay, here's what the formula is going to look like. H over 2, okay, and then y sub 0 plus 2 y sub 1 plus 2 y sub 2 plus, now, give me 3 dots to show that I left terms out, plus 2, and then this is going to be y sub n minus 1 plus y sub n. So like if n was 4, then this would be y sub 4, and this would be y sub 3. Okay, so that's the general formula for the trapezoidal rule. Okay, so now to put it into terms, the trapezoidal rule. I mean, I could have just given you the rule, but then it's like, okay, where does that come from? Okay, you kind of need to know. So the trapezoidal rule, and it is to approximate the definite integral of f of x with respect to x from a to b, and our a would have been here and our b would have been here. Okay. Okay, use t equals, now just repeat that rule, h over 2, that formula, times the quantity y sub 0 plus 2y sub 1 plus, and then put the 2y sub 2 then plus dot 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 plus 2y sub n minus 1 plus y sub n, and close the brackets. Okay, so the trapezoidal rule is to approximate the definite integral. Use this trapezoidal rule with the closed interval AB. Remember, those are both vertical lines, partitioned. That's mean it's divided into, partitioned into, and they will tell you how many subintervals. In subintervals of length. Now, if I gave you the A and the B and told you how many subintervals there are, you ought to be able to figure the height. The height is, take the difference between the A and the B, it's actually going to be B minus A, and then divide it by the number of rectangles or subintervals. So this is your main formula. If they don't tell you what the height is, but if they give you the A, this vertical line, subtract them, divide by the number of subintervals. Okay? Okay. Okay, so draw a little separator there. Now we're going to look at Simpsons method. Okay? Simpsons method uses parabolic arcs. Okay? So, so Simpsons, as they call it, Simpsons rule, is based on finding the area under a curve using parabolic arcs, parabolas. Oh my gosh, when are we ever going to use this stuff? Parabolas, yep. Okay, and it is an even number of subintervals. So this is only going to work if you divide it up into like 2, 4, 6, 8, an even number of subintervals. Okay. Okay, so I'm just going to do it with 2. And on this, this is actually the origin. Okay, and just give me a curve. Okay, from, I don't care, from here to here. Go down. Okay, and we're actually going to estimate, okay, the area underneath a parabolic arc. So we're going to go, okay, and estimate. Okay, I didn't draw that very good. Okay, what is the main formula for a parabola? Algebra 2. AX squared plus BX plus C. Okay, y to the first and an x squared. Okay, that's the main formula for a parabola. Okay, so you're really finding the area underneath the parabola, and this is the curve. Okay, this would be the origin, and we're going to go from negative h. This length would be h. This would be h. Okay. Okay, so we're really going to find the area under the curve, y equals ax squared plus bx plus c. And they label it the area using, they use a sub p for parabolic arcs, just to remind you what it is. It's the definite integral of, and I'm going to switch this to uppercase A, B, and C so my B doesn't look like a 6. So it's ax squared plus bx plus c, and we're going to go from negative h to h. Okay? Now this is very similar to what we did on the polynomials, doing a definite integral. Add 1 to the exponent, divide by the new exponent, and then we sub in. Okay, so on this one, if you take the antiderivative, you're going to have add 1 to the exponent would make that x cubed, divide by the new exponent, divide by 3, plus bx, add 1 to this exponent, divide by the new exponent, so it'd be x squared over 2, plus, and this, there is no x here, so that's like x to the 0, so it'd be cx, add 1 to the exponent, divide by the new exponent. And then we're going to sub in, and we're actually deriving this formula, okay? And we're going to go from negative h to h, okay? So, if we sub into this, we just have, we're going to sub h in first. We sub in the top one first. So you'd have ah cubed over 3 plus bh squared over 2 plus ch. Okay, that's subbing in the h minus. Remember, it's f of b minus f of a. So now you got to substitute in the negative h everywhere you see an x. So we'd have a times a negative h cubed over 3 plus b times a negative h squared over 2 plus c times a negative h. Now we got to simplify that. If you take a negative, h cubed would be negative, and then if you distribute this negative sign, negative times a negative, positive. So we have 1 ah cubed over 3 plus 1 ah cubed over 3 give us 2 ah cubed over 3. If we combine those like terms. Negative, I'm looking at this, negative h squared would be positive. Okay, so I have, and then when I distribute this negative sign, that changes it back to a negative. So these two terms, because this one's going to be positive, when you distribute this negative sign, that's going to make that term negative, so it drops out. Okay, so it's gone. Negative ch, and distribute this negative sign and make that positive ch, so we've got plus 2ch. Okay, so far, combining like terms. Okay, now the author does this. The author factors out an h over 3. That's an h over 3. If you take out an h over 3, what you would have left out of this term would be 2ah squared. Okay, and then plus, this has to be 6c, right? 6c divided by 3, that'd give you 2c and times h, okay? Everybody with me so far? Okay, now, when you're, and this is going to happen to you next year, and I'm not going to be there, okay? Here's what the author does, okay? It equals that. You followed me so far, and then the author does this. Okay, now equals y sub 0 plus 4y sub 1 plus y sub 2. That is a huge leap from right in the middle of the problem, okay? And I had to, you know, when I go through this stuff, it's like, okay, where did that come from? Okay, so then you got to go back and look. When they labeled this, and I didn't label it on there on purpose, now go back and put this as our y sub 0, that y value, which would be this distance up to here. From here to here would be y sub 0. This one is y sub 1, and this one is y sub 2. And I had to go back and figure out, okay, what's the author doing? Well, the author is going back and using this and substituting in these values. Okay, so out at the side, I'm going to do this out at the side with you. Put this in there. Y equals ax squared plus bx plus c. Okay? And my y for this one, it's y sub 0. Okay, so y sub 0 equals, and my x is negative h. So it'd be a times a negative h squared plus b times a negative h plus c. So y sub 0 is negative h squared is positive, so that's a positive, so it's ah squared minus bh plus c. So this is what y sub 0 equals. Okay, now do the same thing for the y sub 1. If I do the y equals ax squared plus bx plus c, my y sub 1, and my x is actually 0. So if I put 0 in there, this first term drops out. You may want to show it so you know where it came from. Plus b times 0, that term drops out, and it equals c. So y sub 1 equals c. Okay, that's my y sub 1. If you did the same thing with y sub 2 and subbed in, y sub 2 is ah squared plus bh plus c. And that's your y sub 2. Okay, now go back. If you figured out, if you sub this back in, if you put this in for y sub 0, and you put y sub 1, put c in for y sub 1, okay, and then put this in for y sub 2, yeah, it all worked. But that is it's like, oh, how did they go from a and c to y's? Well, you got to go back, see how they labeled the problem. Okay. Okay, so now with that in mind, now you can generate Simpsons rule. Okay. Okay, and Simpsons rule is to approximate the definite integral of f of x. So when we do the parabolic arcs, it's also just a approximation. To approximate the definite integral, the area underneath the curve of f of x with respect to x from a to b, you're going to use, okay, and we're going to let it equal to s. T for trapezoidal, s for Simpsons. H over 3 times the quantity y sub 0 plus 4 y sub 1. Now, I only did like two intervals, okay? This only went part way, okay? So the next term is 2 y sub 2 plus 4 y sub 3 plus, it's going to alternate in there, 4, 2, 4, 2, 4, 2, okay? And then put a dot, dot, dot to show you left out terms, plus 2y to the n minus 2 plus 4y to the n minus 1 plus y to the n. Okay, that whole thing is the formula for Simpsons. Forget that a. Hang on. I'm going to see if I can move that a minute. Don't put the a in the... Get that out of there a minute. Yep. Okay. And that's with the closed interval AB partitioned. That's like it's partitioned or divided into an even number of subintervals n of length. Okay, and it's still h equals b minus a divided by, whoops, I wrote that wrong. Hang on. The divided just goes over here. H equals b minus a divided by n. Okay. Okay, now we're going to go through an example. Okay, on page 424, we are going to work number 3 together. Okay, it says use the trapezoidal rule for part A Part B, use the Simpsons rule to approximate each integral with n is 4. That means 4 subintervals, 4 slices. And then on part C, find the exact area using integrals. Okay, so the problem is this. Definite integral of x cubed with respect to x from 0 to 2. Okay. Part A is the trapezoidal rule. But first you want to get a good picture. Okay. So let's look. If we graph x cubed, you guys know what a cubic's going to look like. Okay, and I'm going to do zoom 4, zoom decimal. Oops, I don't have my axis on. Okay, and we're going to go from 0 to 2. So we are actually looking at this area right here. Okay, so I want you to draw a sketch of that. You know, the whole graph of the cube looks something like this, cubic graph, but we're going to go from 0 to 2. They told us 4 subintervals. So from 0 to 2, divide that in half. So that's 1. Divide that in half. So that's got to be x value 1/2. X value would be 1 1/2 or 3/2. Does that make sense? I'm just listing the x values. The width, what's the width of each one of those subintervals? 1/2, right? Okay, so and you can figure that too. If I do h equals b minus a divided by n, my b is 2, my a is 0, and I had 4 slices, so 2/4 or 1/2. That's basically telling you the width of each one of these is 1/2, and we've marked it that way. Okay, trapezoidal rules first. T equals h over 2 times y sub 0 plus 2y sub 1 plus 2y sub 2 plus 2y sub 3 plus, and then the coefficient on that last one is just a 1. This is a 1, and this is a 1. All the rest of them on the trapezoidal rule are 2's. Okay, so then you sub in my h. We calculated that up here. H is 1/2. Okay, so we'd have 1/2 divided by 2. Okay. Now, what's y sub 0? When you look, and you can label it if you want to, this is your y sub 0. This little thing's your y sub 1. This is your y sub 2. It's that y value to get up here. This would be your y sub 3. And from there to there, this would be your y sub 4. Okay. So, if my x value is 0, okay, and my equation is y equals x cubed. So if x is 0, y is 0. So this is going to be 0 plus 2. If this x value is 1/2, and if you put 1/2 back into the equation, 1/2 cubed would be 1/8. 1/2 times 1/2 times 1/2. Okay, this is my x value is 1. If you put 1 back into this, 1 cubed is 1. This is my x value is 3/2. If you put 3/2 in here, 3/2 cubed is 27/8. Yep, plus. And then put 2 in, 2 cubed would be 8. Okay? So all I'm doing is I'm substituting each x value in and simplifying and solving for the y value. Okay, so 1/2 divided by 2 would be 1/4. This would be 0. 2/8 would be 1/4. 2 times 1 is just 2. I could reduce, this is like 2 over 1. I could reduce that. 27/4 plus 8. Now, if you look inside here, simplify. 2 and 8 would be 10. 1/4 and 27/4 would be 28/4 would be 7. 7 and 10. So you end up with 1/4 times 17. So it'd be 17/4. If we divide that out, it would be 4.25. That is our approximation of the area under the curve using the trapezoidal rule. Okay? But you do have to do a little bit of arithmetic. You got to sub those x values, and I subbed them back in. When you sub them back in, you're actually subbing them back into that x cubed, y equals x cubed. Okay? Okay, that's part A. Part B, you do the Simpsons. Simpsons, just write the formula down. S equals h over 3 times the quantity y sub 0 plus 4y sub 1 plus 2y sub 2 plus 4y sub 3. When do I stop? Y sub 4, right? Whoops, sorry, I wrote y sub, should be y sub 4. Okay, and we already calculated the y's up there, so the h we said was 1/2. We already calculated that, divided by 3. My y sub 0 was 0. My y sub 1, I can tell up here it was 1/8. My y sub 2 was 1. My y sub 3 was 27/8, right? And my y sub 4 was 8. Okay, and that's going to give you 1/6. And it'll be 0 plus 1/2 plus 2 plus, you reduce this, to be 27/2 plus 8. 8 and 2 would be 10. 28/2 would be 14, so that'd be 24. So 1/6 of 24 should be 4. So by trapezoid method, we got 4.25. They ought to be close. Simpsons method is 4. Okay, then part C, the last thing is you figure the exact area. Okay, and I'm going to do that over here. Part C, the exact area, the integral of f of x. We can do that right on the calculator. Second function calculate, and we want to go from 0 to 2. Okay, we already have it graphed. So do second function calculate, do number 7, and go from 0, just type it in, 0 to 2. The exact area under the curve is 4. Out of our two methods, which one gave us the better approximation? Trapezoids or parabolic arcs? The parabolic arcs ended up to be exactly the same. Okay, so Simpsons method, for the most part, is probably going to be the better approximation. If it asks you to get the better approximation between Simpsons method or trapezoidal rule, the parabolic arcs are going to be closer. Okay, so on those, you do have to do a little bit of arithmetic, okay, to calculate the y values. Okay.